Good afternoon and welcome back to the Kemper Creative Learning Studio. My name is Daniel, and today we are here with our old favorite, Roll Your Reaction, the show where we will roll for you because we can't have you here. We're really sorry about that. We can't wait to have our audiences back here in the Kemper Theater, but we are going to be doing a whole new set of reactions today. We're going to see what happens. So we're going to learn all about some chemistry, and hopefully by the end of this, we get to blow something up because that's my favorite part of our chemistry shows. So without any further ado, we've got a little bit of learning to do. So here's our intro to elements.
The periodic table of elements is a chart to help us organize the building blocks of our existence. Elements can be defined as units of matter that cannot be broken down further. Take a look at this chalk. Chalk can be broken down into something smaller, like chalk pieces. Chalk pieces can be broken down into something smaller, like dust. Because chalk and chalk pieces can be broken down further, they are not elements. Elements are atoms. Atoms have a number of neutrons, protons, and electrons. These trons exist in two regions of an atom structure. The nucleus in the center is made up of neutrons and protons. The electron cloud outside of the nucleus is where electrons exist. The various elements on the chart are defined specifically by the number of protons. This is their atomic number.
All right, so with that intro in mind, now we are going to start talking about what's going to happen next. We've got to figure out what our first reaction is going to be, and to do that, we're going to use our random reaction generator. You might remember it from our last show. It's right here. We are going to roll it here in our tray and see what happens. Everybody ready? Here we go. We got a 5, one of my favorite numbers. 5 to stay alive, stay at home, stay safe, and stay alive. We're going to go over here and figure out which experiment is number 5. I believe it's on this side. It is. All right, very good. And we are right here in front of my face. All right, so we have got our first reaction, and it looks interesting. The first thing we're going to have, we've got this cool little popper. This is going to be our piece that is actually going to do the reaction for us. Now, this reaction is going to need 3 parts. The first thing we're going to need to do is we're going to need a fuel. So the fuel we're going to use today is actually fire juice. And fire juice is right here. If you ever want to get some fire juice, go straight to the store, ask them for fire juice. They'll send you to the fire department. Then we managed to acquire from a history museum. We got this cool little thing here. Way back in time, people used to take their memories, put them into here, take them to the store, and have strangers look at them before they did. It's lots of fun. So we're going to put a little bit of fuel into there. And then the last thing we're going to need is some energy. And that energy is going to come in the form of a spark today. We're going to be using our popper here. And when I push the red button, then we're going to get a small spark right here, kind of like a very early version of a taser. So I'm going to push this, and I can see a little bit of a spark, but you guys might not be able to. I'll see if I can give you a darker background, see if you can see there's just a little tiny spark, but that's all you need is a little bit of energy to go with our fuel and oxygen. So first we're going to start with our fuel. I'm going to put just a little bit of fire juice in here. There we go. Okay, so we got a good, nice spray there. Now we are going to take that, and we're going to add some oxygen. Now, what is the air made out of? Well, it's made out of mostly nitrogen, about 79%, and then about 20% of the air is oxygen. So I'm going to get some oxygen. All right, that should be enough. All right, so we've got the oxygen in there, and then I'm going to make sure we don't have too much juice. And now we are going to attach it to our device, our launcher. And once it's attached, we now have the fuel and the oxygen inside our film canister. When I push the button, we are going to get a spark, which is going to ignite. And when that happens, we should see a reaction. Now remember, in this show, we're looking for what the sign of a chemical reaction is. So let's find out what the first sign might be. So think ahead from home. Oh, I almost forgot. Safety first. I'm going to protect my ears because this might be just a little bit loud. Now, what's going to happen is when I light this, the fuel and the oxygen are going to combust. And what do you think at home is going to happen? Will this stay in place? Will it go off? Will it stay there? Who knows? Let's find out. In 3, 2, 1. Ooh. Interesting. I smell something. So smells can be a result of a chemical reaction. And what else did you see? Oh, you saw the film canister go flying up there into the seats. Yes, I saw that also. And so that must have been from a rapid expansion of gas. So when you take the fuel and the oxygen and mix in that energy, you get combustion. And that combustion makes the gases expand. And as the gases expand, it flies off and gives us a great reaction. So we heard the reaction, we saw the result of the reaction, and I could smell the reaction. So we actually had 3 proofs that a chemical reaction took place. With all that in mind, let's go to our next video from our wonderful host.
Protons have a positive charge. Electrons have a negative charge. Neutrons are quirky and have no charge. Just like with magnets, positive and negatives pull each other closer. In an atom, electrons are pulled towards the nucleus. As atoms get closer to each other, they can combine together to make molecules.
All right. So we made it through round 1. It is time for round 2. So we're going to roll our random reaction generator one more time. See what happens. Here we go. 3. 3 it is. Let's take this back over here and find out what experiment number 3 is. That is not 3. That is a different number. There's number 3 right there. All right. Ooh, this is a good one. I like this one a lot. So we have got 3 different solutions that we are going to be using. Our first solution that we're going to be doing is we're going to be pouring in some starch malonic acid manganese sulfate solution. We're going to pour some of that right into this little jar, and we're going to pour it up to about the 20 milliliter line. So let me slide that just a little bit, and I'll pour just a little bit. All right. Oh, look at that. Like I planned it in advance, 20 mils. And what color does that liquid look like? Anybody? What color does that look like to you? Did I hear clear? Yeah, clearly it has no color. Okay, so we've got clear right there. Next, we're going to go with our potassium iodate acidified solution. We're going to take some of that and put it the same amount. This is the cool part about this equation is this one uses the same amounts of everything. So we're going to pour 20 right in there. That is a little bit more than 20. So I'm going to pour just a little bit back in. Bloop. Okay, cool. And now we've got that in there. So we've got 2 of our solutions. And now we need our third, which is going to be hydrogen peroxide. Now this hydrogen peroxide is a little bit different than what you might have at home. This is a very concentrated version of hydrogen peroxide. This is actually 30% hydrogen peroxide. What you have at home is normally about 3%. So this we have to be very careful of. It's one of the reasons I get to wear gloves, and I have on my glasses, which these are actually safety glasses, even though they are my prescription glasses. So now I'm going to pour in another 20 mils into this vessel, and that's about right too. So we have 3 liquids so far, 3 of our solutions. Now, can anybody tell me what color are all 3 of them? What do they all have in common? They are all pretty much clear. So what is the hypothesis of what's going to happen next? Anybody? If I pour all 3 of them together, what do you think is going to happen? No, not fire. Not this. No fire. Hopefully no fire. That would be really bad. I know everybody likes to see fire, but we're not going to do fire this time. Well, let's find out. Easiest way. So we're going to take these 2 and pour them into this one. Ready, go. Ooh, we got a cool little blue color. Yeah, blue. Awesome. So we got some blue color right there. That is great. Yes, I love the blue color. Blue is awesome. Blue's a good one. All right. So anyway, what's that? Yellow. Yeah, no, it's blue. Definitely, that's definitely blue. Yeah, guy running the camera is like, no, it's yellow. I'm like, no, it's blue. Obviously, you can see right there, blue. It's like my shirt. yellow. No. Are you seeing things? It's not yellow. It's blue. Certainly. That has to be blue. I don't understand. I'm not sure if we should have a camera person who's colorblind. That's not a good thing. Yeah. Yeah, it's definitely blue, right? All right. Well, yeah, you're right. It's blue. Now it goes to clear and then yellow and then back to, okay, you were right. As always, the cameraman is always right. Best friends. So definitely what we have here, our sign of a chemical reaction is a color change. But not only is it just a straight color change, it's also an oscillating reaction, meaning that the levels continue to go back and forth as they trade off pieces and parts. And as that goes back and forth, you end up with blue, and then it goes back to a yellowish color, to a clear color, back to blue, all from 3 clear liquids. There's our clear going back to a yellowish, and then it goes to blue. Kind of a fun reaction, if you ask me. This is one of my favorites, and it's always fun with our live crowd because, well, it changes colors, and the oohs and ahs are very loud. I'm sure I can hear some from outside from everybody who's streaming this right now that you're all oohing and ahhing over this. So that was a lot of fun. Let's go to our third video before we get to round number 3. I'll see you in a minute.
The electron cloud is outside the nucleus where the electrons live. This cloud has regions where an electron can be found. Each region, or shell, has a certain number of slots that can be filled. The first shell closest to the nucleus has 2 slots. The next shell has 8 and more as you move further away. Electrons fill up slots starting closest to the nucleus. Once the slots are full, electrons will begin filling up the next shell further away. When slots in a shell are empty, this valence shell, the outermost shell, is where the fun in chemistry happens.
All right, folks, we are back. And I don't know about you, but round number 3 should be interesting because it is only 1 round from our combustion round. Round number 3, we're going to roll to see what type of reaction we have next. Ooh, it's a 4. That was our most popular number a few weeks back. If you were here with us for our very first show, number 4 was the number that we rolled every time almost. So we're going to go see what number 4 is this week. Number 4 in round number 3. Oh my. You are in for a treat. This one is cool. All right. So I've got almost everything I need on here except for I need one thing. I need the most dangerous liquid on Earth. H2O. Yeah, H2O. Most dangerous liquid on Earth. Just watch the news and you will find that it is very, very spooky. It's involved in almost every natural disaster. So we're going to pour some water right here into this cup, and then we are going to put that on there. Now, some people might accuse me of tomfoolery with this experiment. So what we're going to do is I'm going to turn on our nifty-difty thermometer, and I'm going to measure our water. Our water is, oh, look at that. Somebody was a silly goose and put it on Celsius to confuse me. But we have 68.5 Fahrenheit right there. Oh, let's see if I can get that so that you guys can actually read it. Nope, I can't. But it's close. Anyway, 68 degrees. So we're going to take that, and then we are going to, that's going to have a couple of wood planks. Take a little bath in there. We're going to soak those up nice and tight. Okay, so we've got those in there. Now we're going to take our solution, or our 2 elements. We've got some barium hydroxide. We're going to take a little bit of that. We are going to take a big heaping spoonful of that. Pop it right there. Let's take 2. This is a big show. Got a great audience out there. You guys deserve the best. So we're going to go with 2 big heaping spoonfuls of our barium hydroxide. Next, we are going to take our ammonium thiocyanate. That's right. Not something you can just go pick up at your local hardware store. We're going to take a little bit of this. Let's take that top off. Very good. And another heaping spoonful. I need smaller fingers. Again, we got a white crystally substance, so we're going to do one of those in there, and then we're going to do, if I can get down to the bottom of it, Another big piece. And a little bit more. There we go. Okay, so I think we're going to be good. Let's find out what happens next. I'm going to take our stir stick and start to mix it around. And if you watch this start to happen, you can start to see down there, we've got some liquid forming. Now, the other thing that's going to come off of this, and I can actually make this speed up just a little bit, but let's see what's happening first with our temperature. We are down to minus 14 degrees Fahrenheit. So 14 degrees below 0 Fahrenheit. That is a very, very cold. And for those of you that at home that do not have smell-o-vision, this smells just like the liquid that comes out of cats. Yeah, you're in trouble if you smell this around your house and you own cats, because they've been bad. Woo! That is a great smell. All right, so we're going to take that very cold temperature, and we're going to see what happens if we put it onto these wooden planks, just like so. Once again, we'll take another reading. Oh, it's still at minus 14 degrees below 0 Fahrenheit. Any theories on what's going to happen with our wooden planks that have been dipped in water, put next to glass that is minus 14? Any ideas? Anybody have a clue? No? Let's see what happens. Oh, looks like somebody's going snowboarding. He lost his ski. But that is so cold that it actually froze our plank to the bottom of our jar right there, because it's so cold it froze that water, and I cannot even tug that off if I try. I will not try too hard because that is glass and I don't want to break it. That's not a lot of fun. So there we can see we've got what's called an endothermic reaction, and that endothermic reaction means that it is actually getting colder by throwing away heat. And we get very, very cold, and as it gets really, really cold, everything slows down and it kind of starts to contract, and that cold then froze the water that was on the plank, which froze it to the bottom of the jar. Kind of a cool one. All right, well, it is time for round 4, but not before our last final video of the show. So we will be right back with you in just a moment.
Usually, atoms want to fill the empty slots in their valence shell. To do this, atoms will group up and will beg, borrow, steal, exchange, or often share electrons. When two or more atoms group up, they merge together and become a molecule. Molecules are held together by bonds. There are different kinds of bonds depending on how electrons fill the slots. Creating, adjusting, or breaking these bonds are how we get chemical reactions.
Breaking bonds. That's where we're going to have a lot of fun, because round 4, as everybody knows, is the combustion round. And the combustion round is my favorite because that's where I get to blow stuff up. Cool. All right, so we're going to take our random reaction generator, roll it one more time to see which of our combustion reactions we're going to have. Oh, boy. We rolled a 6, folks. Yep, this is the one the boss doesn't like so much. Number 6. All right, let's take number 6. Let's go over here. I know exactly where this one's at, because we warn everybody, don't do number 6, because, well, with a live studio audience, it can get a little hairy. Save that for a second. Now I need a tray to put all this on. Now combustion, if you've been with us before, is really fun. We're going to take some fire powder. The fire powder is basically just dehydrated fire juice. We're going to put a little bit of fire powder right here into this little pan. Oh, here. Why not use technology if you can? We'll just put that right over there. All right, cool. And we're going to put in a little bit of fire powder. Yeah, just like that. That's almost enough. All right. There. Okay, cool. Now, fire powder. Remember, combustion, we're going to need 3 things. We need fuel, fire powder. We need oxygen, plenty of that. And we've got an energy source. And here, audience, I'd like you to meet Pete. Pete, here's the audience. You guys have all met your match. We are ready to go. We will take that, and we need to light our match. This isn't how you guys light matches at home. You are not living your full life. This is how we light matches at Exploration Place. Here goes. All right, so we've got our match lit, and we're just going to go right down into that fire powder in 3, 2, 1. Look, I made a popsicle. No, that didn't work out like it was supposed to. But let's try that again. I know this fire powder is very flammable because it says fire powder right on it. It has to be flammable. So let's light our match from the other end. Maybe it was just that end. That end didn't work, so we're going to go 3, 2, 1, right down. Didn't work. All right, so... Oh. I should have learned from the last show. You need 3 things for a fire powder. For combustion, you need fuel, you need energy, and you need oxygen. And when I put it down in there, I'm smothering it. Just smothering it, and it takes away all the oxygen. So what if I was to aerate it and add a whole bunch of oxygen with the fire powder and the energy? You think we might have some more fun? Yeah, so do I. So we're going to take our tray. We're going to move it over here just a little bit. We're going to move this out of the way. And we're going to take our fire volcano. That's right, the fire volcano. The fire volcano has been preloaded with some of our fire powder. But you know what? I don't think it's got enough. So we're going to add some more fire powder here to our mix. All right, cool. So I've got my fire powder ready to go. I'm going to take a big, nice... That's a big tablespoon. We're going to put that right in. What do you guys say? One more? Yeah, why not? One more. So we go one more in there. Okay, so we've got our fire powder. We are ready to go. Let's cover up the fire powder before we create the fire. Always helpful. Move this little tray out of our way. We'll get set up. So we have got our fire powder in the bottom of our volcano. We have got our energy source, which is going to be this propane torch. When I turn it on, I will lock it on, and it will be hitting the fire powder as it flies out of the top of the volcano, where it will then get energized. But we need to do that. So what do you think? Should I just blow? No, that wouldn't work. What if I was to use this? Ah, yes. This is a compressed air. So we're going to take compressed air. We're going to shoot it into the bottom of the tornado. And into the bottom of the tornado is then going to shoot out of the top. But before I can do that, I need some safety gear, because safety first. We want to make sure that we are safe doing science. I do not need my ears for this one, so I just need this. And I think I've got all the other safety equipment on here. We are good to go. Okay, so I'm going to put my mask down, which is going to make me sound a little weird, but that's okay. Might just be me. I don't know if the folks want us to turn the lights down a little bit, but here we go. In 3, 2, 1. Whoa! Woohoo! Oh, that was a lot of fun. I don't know about you guys, but I feel like I've been through something. I'll use this to clean off in a little bit. What we saw there was a combustion reaction. We saw our fire powder mixed with the energy and the oxygen in the air, and that created, you guys couldn't see it at home, but that was a lot of fire. We had a lot of fire going on. That was a lot of fun. I really thank you guys for joining us for another one of our live science shows here. It is part of our Stay-at-Home STEM series. We look forward to seeing you back here at Exploration Place when we can reopen. Till then, stay home, stay safe, keep washing your hands, and we'll see you soon. Thank you.